In this video, you want to find a tension in the rope using these pure exams questions. Now let's analyze the question here. So what we are given is that a bucket of water is being pulled from a well. So let's say you can, if you don't know what a well is, you can just look at that to be a river, right? So, or maybe something of that nature. So you are pulling the water from, so assuming this is a well, this is the nature of the well. So, or maybe a tank, so you can call it, or maybe something like a tank. So there is water in the tank here, right? So if there's a water in the tank here, you have to pull it out with the help of what, another rope here, and then the basket is being attached to, right. So the bucket here is being attached to to the rope. So you are here pulling what, the what, the rope, right, just to get access to water. Is that okay? So that is what, this is what you are calling the tension, right? So this will be the tension uh, between you and the what, and the load, right? So that is the tension. Now the question that we are giving, they say that the bucket of water of mass 20 kilograms. So this bucket here is being weighed to 20 kilograms. So that is what we are having. It's being pulled out of a well. So you are being asked to find the magnitude of the tension in the rope, right? So the magnitude of the tension in the rope. So that magnitude here is the length, right? So the length of this rope when we are moving, or we are pulling the thing at what, a constant speed. So pulling that thing at a constant speed, meaning that we are not changing. So if you are pulling it one, two, three, like that, now the speed is constant. Is that okay? So that is the first part of the question. So let's see how to analyze that. With the word tension here, we can let T be the tension, right? So T being the initials of the tension. So let T be the tension of in the rope. So the tension in this rope here, right? So the tension in this rope is what we are represented by T. And you can see that the net force, right? The net force on the load. So what I mean by the net force here is that if you say, let's go back to, so let's say you are a salary worker, right? So you receive a paycheck, something of that nature. Then let's say you receive 200k, right? So 200k means that maybe $200 per month. So out of this $200 here, you take tax out of this and some other expenses, right? Some other expenses here. So after deducting everything from what, this amount, what is left is what we call what, the net of what, the net of maybe your income, right? So let's say you are left with, let's say 150k, right? So this is what the net that you have after deducting all the first. If you bring this idea to what you are trying to do here is that the net force on the load is that you have to deduct the tension, right? So this is the tension. So the tension minus the force, right? So that will give us what, the force that you are applying on the load, right? So the force here and then the tension being out, we are going to have is the net force that we are being applied. Is that okay? So that's very simple. You have to deduct what, the tension and the what, the what, the force that we are applying. So to get a what, the net force on the load, right? So that's straightforward here. So the net force on the load will be equal to what, the tension minus what, the mass multiplied by what, acceleration due to gravity, right? So this is very simple to understand here. Okay, now what you are given, so with the, so you should find the magnitude of the tension in the rope when it is moving with a constant speed, meaning that if you are pulling it out with a constant speed. Okay, so here you can see that the net force here, so remember the force, that is m here, right? So mass multiplied by the acceleration here, then that is equal to, right? So your force that you are applying, so the force that you are applying here, you have to take the tension out of the load, right? So out of the load here, so you are going to have what, the net what, the net force that we are applying, right? Okay, so that is the T minus or the M. So here we are giving the M, right? We are giving the M, and then we are also giving the gravity Is that okay? But remember, one key thing you have to pay attention to here is the A here is what the acceleration, right? So acceleration, if you are moving at constant speed, there's no change. Is that okay? So as you are moving, if you are moving straight forward at a certain speed, you don't change. You don't go up. You don't go up or in other or come down, right? Is that okay? So we are moving at this constant speed, meaning that the velocity here, the speed here is zero, right? So the speed here is zero. That is one thing you have to pay a close attention to. So the speed here will be zero. So meaning that our A here is equal to zero. So you have M here multiplied by zero, right? So equals to the T minus mg. So this mg here, you know what the G stands for. That is the gravity here, and the T is the tension. So this guy will give me zero, right? So this guy here will be what, zero, and then minus what, that is equal to T minus what, mg. Right? Remember that from the question we are given the gravity does will be equal to 9.8. We are just going to substitute, right? So substitute here will give us what the M was what, 20 kilograms. So that's the mass of what, that load here. So if you replace the M by what, 20 kilogram and the G by what, 9.8, we are going to have T minus what, 20 multiplied by this guy. So that will be what, T multiplied by 196 newtons, right? Remember we are dealing with force. Is that okay? So that should be what, 918 newtons. Remember the thing you should find what, the T, which is the tension. So you add what, 198 196 from both sides of the equation. So you are going to have what, your tension to be equal to 196 Newton. That is the tension at the point where you are moving at what, a constant speed, right? So you are pulling the rope at what, a constant speed. Okay, the second part says that you should find the tension when you are pulling the rope at what, 0.3, meaning that you are moving from 0 to what, 0.3. Is that okay? So moving from 0 to 0, what will be the tension? So let's find out that. So moving at the acceleration of 0.3, right? 0.3, that's what the question says. So the formula remains the same. Is that okay? The definition here remains the same. So that is the difference in the tension and the load here is equal to your net force that we are applying on the load, right? So by here, we are no more moving at the constant speed. We are moving at the speed of what? Acceleration of 0.0.3, right? So wherever you see the A here, you replace that by what? 0.3, and then do your calculation, right? So just replace. This is just a straightforward. Then you make T the subject here. So looking for T here, if you look at everything perfectly, you should have your T. This is all mg, right? So mg here means m multiplied by G. So m was 20 multiplied by 9.8 here, and that is equal to m multiplied by 8. So m is the mass here. That's the 20 multiplied by what, 0.3, right? Is that okay? So if we do this calculation here, should give us what, 198 is equal to 6. Okay, don't forget, if you enjoyed the video, don't forget to subscribe to the channel, give us a comment and like if you have any issue, right? Okay, so there, here we are going to add what, 198 to both sides of the equation. Remember that we are looking for the T, which is the tension. So that this tension will be equal to 6 plus what, 198. So we are going to have the tension to be what, 202 Newton, right? At the point whereby we are moving at the acceleration of 0.3, and then we have the tension to be what, 198 when we are moving at what, a very what, constant speed, right? So when we are pulling the rope at constant speed, this is what our tension. Then if you are moving at what, 0.3, this is what the tension in that rope.